Welcome to This Is My Architecture. I'm Liam, here in New York City with Patrick from 128 Technology.
Hi, thank you, Liam, for having us here today.
So tell me a little bit about what 128 Technology does.
128 Technology is a software-defined networking company that makes IP routers.
All right, so we're here today to talk a little bit about a problem you solved for one of your customers, correct?
That's correct. Our customer was a SaaS provider that had that used AWS for hosting their services.
So what were some of the challenges that the customers of this SaaS platform faced?
Well, the SaaS platform was trying to sell to end customers, and this is representative of one, and they had many, many locations. And they typically had issues with getting connectivity for all the abstracted data that they were obtaining from different things and services and span port monitors and things like that. So they wanted to abstract that data into AWS regions.
And these could be sites of what size? Are they large sites, small sites?
They're various. Sometimes they're small, and so direct connect isn't an option, or it's too expensive, or complex.
All right, so what you have here, it looks like connectivity into AWS, but you're not using direct connect. And this isn't VPN either, is that correct?
That's correct. We've invented something called secure vector routing, and it starts at one of our routers and goes all the way through the internet and terminates at another one router, and this is we called secure vector routing.
So your technology allows you to actually communicate through the internet securely in an abstracted manner. Is that correct?
Exactly. We abstract this data through this vector, this secure vector, which starts at this location and ends at that location. And the data goes through that secure vector all the way to the EC2 servers inside the AWS region.
So without VPN, how do you achieve security?
The secure vector route puts a cookie in the first packet that goes through, and it essentially establishes all of the state necessary and all the security necessary for all the packets in the session.
All right, so the packet identifies the session, but how do you keep it secure?
We actually do AES encryption between these two routers, and all the key management is done as part of the overall management done by the Conductor.
So why wouldn't a customer use like an IPsec VPN?
Well, the IPsec VPNs are useful, but they require a lot of planning and take time. In this case, the customer and the owner of the firewall is not the software as a service provider that's in the AWS regions. So there's an issue of how to get it done.
So this reduces the kind of onus on the customer side as far as what configuration. It's essentially put the routers in, some firewall changes, I assume?
Minimal firewall changes. This operates with Assault Minion, and so supporting that is the only change required.
All right, so you mentioned the Conductor. So let's go into how the Conductor does what it does for your environment.
Yeah, the Conductor is sort of the master of all of these slave routers. It supports zero-touch provisioning, which allows these instances to be started and to be maintained. It's Assault Master for the Assault Minions that we have here, and so it provides all of the orchestration required to run this network. And it's owned and operated by the software as a service provider, which is actually abstracting this data as part of the service.
Very nice. So, as the saying goes, everything fails all the time. I see here it looks like you've dealt with some of these scenarios. How do you maintain availability of your application?
Well, we do it in many ways. Initially, I'll start with picking the correct AWS region. So we actually communicate to each region from each customer site using a protocol called bidirectional forwarding detection and the response. And we know the latency to each region, and this customer site will pick a region based on those results. And then it will start sending its packets to the best region, which in this case is US West 2.
All right, so you're active. What happens if something fails in your environment?
Okay. In the case of these two routers over here, we have an elastic IP address on each of them. All four of these in elastic IP address. And should one of these routers fails, we move this address here using AWS APIs and restore this. It actually is restarted, and then the address is moved back.
So what happens if something on premises fails?
If something on premises fails, we rely on the old standard router-to-router redundancy protocol called VRRP.
All right, and what about the conductor? What if the conductor fails?
If the conductor fails, we rely on AWS capabilities for it to be auto-managed and restarted.
How do the conductors work? Are they active-active? How do they manage with two of them?
Yeah, they communicate exclusively with REST APIs to all of these devices. The REST APIs, they gather data, they gather analytics, they gather operational metrics and alarms and any information that's necessary to provide the SaaS owner with a sense of how the service is operating.
So I see the conductors here manage the environment. Do they also provide anything else, analytics or something like that?
Yeah, they do provide analytics, and because we're a session stateful router, we can provide all kinds of session analytics of all this abstracted sessions from here. We can provide detailed analytics about them, including their jitter, latency, packet loss, retransmissions, things like that.
So what you have here is a highly available, secure, multi-region hybrid architecture that also abstracts the network complexities from a SaaS customer, which could be tens to hundreds of sites, and that SaaS provider. This is a fantastic architecture. Thank you for showing us this.
Well, thank you, Liam, very much for having us.
And thank you for watching This Is My Architecture.